Welcome to the graphing review. Today what we're going to do is we're going to be going over the review of all the different types of stuff that involves graphing, types of polygons, and types of rational numbers. Now, at the end of this lesson, which is a multi-day, even over a week lesson, you'll be able to find the X and Y intercepts of problems, determine where the asymptotes are, the horizontal and vertical, determine what the end limit behavior is, find out when the functions are increasing, decreasing, find out when they're concave, up or down, find the critical numbers and the critical points and the inflection points, and graph polynomials and rational functions. So, just going to do about 11 examples. You can keep on banging back and forth. Whenever you want to pause it, stop, that's fine, and then continue on when you need to. Now, first thing is X-Intercepts. I'm going to walk you through the first two problems, and then you can try a bunch on your own. So, in order to find an X-intercept, all you really have to do is you have to set f of x or y equal to 0, and you solve for x. In some cases, you may need to use this little symbol right here, and that little thing right there is the quadratic equation. Now, in this case, you do. Now, because this is raised, you can't see my head probably, because this is raised to the fourth power, what you need to know is you could solve it like a regular quadratic, because this is squared and this is a number. So you could even use the quadratic equation for that, even though it's technically supposed to be for things that are squared. So this would be your A would be 1, your B would be -6, and your C would be -3. You type it into the equation, -6 plus or minus. Well, this becomes a 6 plus or minus. -6 squared is 36, and this would be plus 12. 36 plus 12 is 48. 6 plus or minus square root of 48 over 2. So you do 6 plus square root of 48 over 2. And you get x squared, because remember this is to the fourth power, equals 6.46, and then you do 6 minus radical 48. I'm sorry, well you take the square root of this, you get 2 plus or minus 2.54, x squared. Now this is a negative 0.9, and you should remember that you can't take the square root of a negative number, so that's undefined. So you have two x-intercepts at positive and negative about 2.5. To find the y-intercepts, you set x equal to 0. So f of 0, right, f of x is 0, 0 to the fourth, minus 6 times 0 squared, minus 3. 0 minus 0 minus 3 is a -3. So you have one y-intercept of -3. Once again, x-intercepts are where the graph crosses the horizontal or the x-axis, y-intercept, or where they cross the vertical axis. Now, in order to find vertical asymptote, that is where f of x is undefined. All right, so polynomials, oops, sorry, there's y equals -3. There are none, and the reason for that is polynomials are never undefined, all right? Unless you have a radical involved, which we don't, but you wouldn't use that because that would just be a domain and range issue, all right? End behavior, this is what we just did. You plug in negative infinity into the equation. So you take the highest degree term using L'Hopital's rule, which is x to the fourth. Negative infinity to the fourth is positive infinity. Good. Right here, limit of f of x as x approaches infinity. Infinity to the fourth is also infinity, and that means up. So what it means is, as you're going to the left, your graph is going towards infinity, so it's shooting up. And this means as your graph is going to the right, your graph is shooting to infinity, positive infinity up here, so it's also going up. Horizontal asymptotes are where the limits are the same. So right here, the limits are both infinity. However, it has to be the same number, okay? It has to be bounded. This is unbounded behavior, so you can't have a horizontal limit there. All right, because you can't have a horizontal limit going across at infinity, because infinity is shooting up forever, right? Makes sense? There are none there either. Now, polygons actually do not have any asymptotes. All right, so when you have a polygon, no asymptotes. So you can just automatically go none, none. Anytime you see a polygon, no asymptotes. Got it? Perfect. Now, next step is the increasing and decreasing on a function. So this is your critical numbers, your critical points. So let f be continuous on the intervals. So we did this already, so I'm just reviewing it real quick. First thing you do is you find your critical numbers. You set f prime x equal to 0, f prime x equal to undefined. Then you solve for x. Then you set up your table. Okay, in the table you find your intervals. Negative infinity to whatever your critical number is, that critical number to the next one, to the next one, to the next one, to positive infinity. All right? Now, what you're going to do after that is you're going to find the sign and the test value of the intervals. So, after you create the intervals, You pick a number between the two intervals, right? You plug that into your f prime, you plug it into your derivative, all right? And if the number is positive, the function is increasing. If the number is negative, it is decreasing. All right, to find the actual critical point, you take the critical number and you plug it back into the original equation. That gives your x and your y value, all right? So let's do an example and make it simple. So when f prime x equals 0, because this is a polygon, remember we said before, it can't be undefined, all right? So we're going to find critical points and when this graph is increasing, decreasing at the same time. So first thing, we derive this. Derivative of this is 4. 4 minus 1 is 3. 2 times 6 is 12. 2 minus 1 is x, and then negative 3 becomes 0. So you take this equation, you set it equal to 0. Now you solve. Can you pull anything out? Yeah, you can pull 4x out, right? So now what you do is you take each one of these pieces of the equation and you also set them equal to 0. So 4x equals 0, meaning 0 divided by 4, x is 0. Your first critical number, x squared minus 3 equals 0. Add 3 to both sides, x squared equals 3. Take the square root of that, and x is a positive or a negative 3. So that means I have negative radical 3, 0, radical 3. You always want to write them in ascending order. Now, find the critical points. That's what we're doing next. So we have the critical numbers. All right, that's going to be helpful for our graph down here. To find the actual critical points, you're going to take these three numbers and plug them into the original equation, okay? Because these are our x's, we need to know what the y's are. And these points are the exact points where our graph shifts from increasing to decreasing. So I take 0. I plug it in 0. Look, there it is. 0 minus 3 is negative 3. My first critical point is 0, negative 3. And we'll be using that later. If you want to put it on your graph now, you can. Next one, negative radical 3. Radical 3 to the 4th, well, this is easy. Radical 3 squared is, negative radical 3 squared is 3. 3 squared is 9. So this is technically 9 minus 6 times 3. 9 minus 18 minus 3 is negative 12. You can also use a calculator, but if you do use the calculator, make sure you put the negative radical 3, the whole entire thing, in parentheses, or else you're going to mess up your signs. And then if you do radical 3, you're also going to get negative 12 as an answer. So these are our answers. And radical 3 falls somewhere between 1 and 4. I don't know the exact number. All right, so these are our 3 points that we're going to plot on our graph. All right, good. I think it's like 1.7. Yeah. All right, all between 1 and 2. So our intervals now, negative infinity, 2. The lowest of these numbers is the negative, so negative 3, radical 3. You have to put them in ascending order. Negative 3, then you got the 0, then you got positive radical 3. All right, number between these two. So then you get your intervals. Good. Negative infinity to negative radical 3. Negative radical 3 to 0, 0, 3. And remember, these aren't points, these are intervals. These are all x values. So I picked a number like negative 2. If I type negative 2 into my derivative, 4 times negative 2 to the 3rd minus 12 times negative 2 equals negative 8. That is a negative number. Negative numbers are decreasing in value. Okay? Next one. Number between these two. Say negative 1. Negative 1. 4 times negative 1 to the 3rd is negative 4 plus 12, which is 8. Positive number, which is increasing. All right? We good so far? This one right here. Number between 0 and radical 3. Positive 1, okay? 4 times 1 is 4, minus 12 is negative 8. Negative 8 is a negative number, which is decreasing. All right? And then a number between these two would be like a positive 2. 4 times 8 minus 24 is indeed 8. Positive number increases. So what this means is my graph is going to go down till it hits this point. After this point, it's going to go up till it hits this point, and then it's going to go down till it hits this point, and then it's going to go back up. All right? That's all this stuff means. Now what we're going to do is we're going to go over how to find the concavity. Now this is using the second derivative. Same exact thing. So you're going to find the critical numbers. You're going to use these numbers to do the test intervals. Now they're all called critical numbers just because that's where stuff happens. The critical numbers, though, are used to find points of inflection. So you're going to set your second derivative equal to 0. All right? You're going to set your second derivative equal to undefined if it's a fraction. All right? And then you're going to solve for x. And those give you your actual critical points. You take those critical points, you plug them into the original equation, it gives you your points of inflection. Determine if the sign is, so once again, you're going to set up your intervals between those critical numbers you got from the second derivative. You're going to take test values between those intervals, right? Plug those test values into the second derivative, and then if they're positive, it's concave up. If it's negative, it's concave down. That's it. So let's go attempt one of these. So with your inflection point, right? Since this is a polynomial, we only have to worry about setting it equal to 0. So you have your first derivative that you already found from your previous thing when you found your critical points, right? So what you're going to do here is you're going to derive that. 12x squared minus 12 equals 0. So solving for x here, you could take a 12 out if you want, or you could add a 12 to both sides. It doesn't really matter. Because in this situation anyway, you divide everything by 12 and you get x squared equals 1. So since x squared equals 1, anytime you have x squared equals number, it's plus or minus. So x equals plus or minus 1. Those are my two critical numbers I'm going to use to find my inflection points. Now to find the actual inflection points, you plug these critical numbers into the, not this equation, but the original equation. So I'm going to plug 1 and negative 1 in here. So when I plug negative 1 in here, negative 1 to the fourth is 1, minus 6 times negative 1 squared is negative 6, minus 3 is a negative 8. So my first inflection point, where it changes concavity, is negative 1, negative 8. My second one, I plug 1 in there and I get the same answer. 1, negative 8. So I have 2 points. So one's, you're going to change from concave up to concave down. All right? Doing good so far? Now what you're going to do is you're going to take your inflection, or your critical numbers from your inflection points, and put them in here. What's smaller, negative 1 or 1? Negative 1. And then you got your 1. So now you set up your intervals, negative infinity to negative 1, negative 1 to 1, and 1 to infinity. Pick a number between these, your test values. Well, I'm going to pick negative 2, but whatever you pick, you're going to get the same answers for these. So say you pick negative 2, plug it in here. 12 times 4 minus 12 is indeed 36. All right, say I pick negative 10. I would still get a positive number. Positive numbers mean you're concave up. Good number to pick between these is 0. 0 is always an easy one. 0 minus 12 is indeed negative 12. Negative numbers are concave down. And then the number between these two, I'll pick 2. 2 will yield the same answer of 36. Positive number, which is concave up. So this gives me my concavity. So now what we're going to do is we're going to take all this information and create an actual graph now. And this is where the fun happens. So your intercepts. How do we know the intercepts? Well, you found them. That was in the top left box. All right, we found them to be plus or minus 2.52. So the x-intercepts go in this graph. So since this is all go up by 1s, 1, 2, and about a half is here. 1, 2, and about a half, negative half is over there. All right. Now our y-intercept, we found before to be negative 3. So since all these go by 1s, 1, 2, 3, you put our y-intercept on the graph right here. All right. Sometimes your x and y-intercepts will both be at 0. That's okay. Are we all good so far? Awesome. Now, asymptotes, because this is a polynomial, right? We said there are no asymptotes, no x or no y. End behavior, what is it doing as it's approaching infinity? Well, as it's approaching negative infinity, it's going up to infinity. And you could write this on your paper if you want. You don't have to, though. As you approach positive infinity, your graph is also going up to infinity. So we know the end behavior of these graphs. The graph's going to be shooting up in the air at the end. Critical points. We're 0, negative 3, negative 3, negative 12, square root of 3, and 12. So we're going to plot those points. 0, negative 3 happens to be my y-intercept. That's 100% okay. Negative 1 point, I think like 7-ish, negative 12, and then 1.712. So those are my 3 critical points. Now, between these critical points, you want to see if your graph is increasing or decreasing. Now, I like to put little dashes like this just to help me out. They're not asymptotes. But what I can tell is, if we go back to the slide right here, we said between negative infinity and negative radical 3, our graph is decreasing, so it's going to go down. And then we said our graph increases till it gets to this point, it decreases, and then it increases again. Now, once again, you don't have to write this stuff on this. You can use arrows if you want, but this is just to show you. So we have a decreasing till we get to this point, then we're going to increase, then we're going to decrease, and then we're going to increase forever. So far it makes some sense, right? But wait, now we got points here. Ooh, so we have to pass those points as well. So now let's look at our inflection points. We found them to be negative 1, negative 8, right? And 1, negative 8. Now, remember between these 2 points, stuff's going to happen on this side, between these two, and over here. So this is where we use our concavity. So it says between negative infinity and 1, our graph is concave up. It says between negative 1 and 1, our graph is concave down. So concave up means it's kind of like a U, and then it's going to be a concave down, and then concave up again. All right? So now we use all this information to put together a graph. So obviously we have to connect the dots. It's going to look like this, right? So that makes sense. That increasing, decreasing. Good. Now we just do our concavity. So we come down and we draw like a U, a concave up U. All right? Now between these two it's concave down, but you have to hit this point and go back down. So that's like an upside down U. All right? It doesn't have to be perfect. You're just getting the idea. Now between this point here, it's another U, right? But it has to hit this point and then go through that point. And there's your graph. And right there is a graph that you guys probably never thought you can graph, right? Ready to try another one? Hopefully you are. Let's go. All right, I want you guys to attempt problem number 2, and then we will go over it. Ready? First, X-Intercept. Set of X equal to 0, and you solve for X. Now, how do you solve for X? You can pull an X out, and then you can actually factor this. Factors of -2 that add up to -1 are X times X minus 2, X plus 1 equals 0. You set all three of these equal to 0. X equals 0, so X is 0. X minus 2 equals 0, add 2, X equals 2. X plus 1 equals 0, X equals -1. Find the Y-intercept, you set X equal to 0. Well, when you set them all equal to 0, 0, 0, 0 is a 0. Asymptotes, polynomial, oops, Y equals 0. None for polynomials, all right? End behavior, horizontal asymptotes, none for polynomials, none. End behavior, as you approach negative infinity, pick the highest degree term, L'Hopital's rule, to the third power. Negative infinity to the third power is negative infinity. Means the graph is going down as you're going that way. Right, that's the one endpoint. Positive infinity, so as we go this way, infinity to the third power is positive infinity, so the graph is going to finish going up. So there you go. You got a bunch of good starting points for your graph. Now we go into the critical points. Now this one's a little more difficult. Why don't you guys attempt this? Uh-oh, what do you think that is? Set f prime x equal to 0 because it's a polynomial. Don't need to set undefined. Derive this. 3x squared minus 2x minus 2 equals 0. Now, you can't factor this. So since you can't factor it, you have to use the quadratic equation. ax squared plus bx plus c equals 0. And then you plug it in here. Your a is 3, your b is -2, your c is -2. And it's really not that difficult. -2, plus or minus, just make sure you put all your negatives in parentheses. 4 plus 24, which is 28. 2 plus or minus 28, or 6. 2 plus radical 28 divided by 26. 2 minus radical 28 or 26 gives you -0.56, 1.22. What do we do with these numbers to find the actual critical points? We plug them into the original equation. When you point -0.56 in there, you get 0.63 or 63 hundredths. And then you plug 1 and 22 hundredths in there, and as an answer you get -2 and 11 hundredths. Good? Awesome. So these are my 2 points where my graph is going to go from increasing, decreasing, or decreasing to increasing. Otherwise known as my extrema. Remember extrema? All right, so anyway, -0.56, 1.22. Negative infinity to -0.56, -0.56 to 1.22, 1.22 to infinity. Test value, let's pick -1. Take -1, you plug it into this equation. 3 times 1 minus 2 times -1 is +2 minus 2 equals 3. 3 is a positive number. That means the graph is going to increase till it gets to this point. After it gets to this point, number between these two is 0. 0 minus 0 minus 2 is -2. Negative, it's decreasing. So it increases till it gets to this point. Once it gets to that point, it's going to start decreasing. All right, till it gets to this point. Once it gets to this point, let's see. We plug 2 in here. 3 times 4 minus 2 minus 4 minus 2 is indeed 6. That's positive increasing, so it's increasing. So it goes up till it gets to this point, down when it hits this point, and then it shoots back up. All right, let's see if that works. Now, inflection points. Go. Set f prime x equal to f double prime, or the second derivative, equal to 0. There's your first derivative we found from the previous answer. Derive it, 6x minus 2 equals 0. 6x equals 2, because I added 2 to both sides. Divide by 6 and you get x equals 1/3, or 0.333. So we only have one inflection point. Take that point, plug it into the original equation. When you do that, you get negative 0.74. So our example, or our inflection point where the concavity changes is 1/3, negative 0.74. Well, negative infinity to 1/3, 1/3 to infinity. Number between these two is 0. 0 minus 2 is negative 2. Negative number, concave down. So we have a downwards concavity. We get to this point, and I bet it's going to be upwards. Pick one. 6 minus 2 is 4. Upwards concavity afterwards. Right? So sometimes these are very easy. See how much quicker the second one goes? Now, use all the information you got from the previous graphs to finish this one. Your intercepts we found to be negative 1, 0, and 2. So we're going to cross the graph in 3 points here. Y-intercept was 0, so it's the same one here, so you don't have to repoint it. Asymptotes, we said there were no x and no y. End behavior, we said as you approach negative infinity, it's going down. So our graph is going to come up here, do something up here, come back down, and probably end up over here. All right? Critical points we found to be negative 0.6-ish, 0.63, so about here. And then 1.22, negative 2.1 over here. So now look, this is a little better example. We're going to look like this. So now we know what the graph looks like. Let's just deal with our concavity, because we know from here to here it's going to be increasing, decreasing, increasing, and that was from the little chart we made. Inflection points, there's only one, 0.33, a third, and here. So when we said when we hit this inflection point piece, this is concave down, concave up. So what this means is our graph is going to increase here, decrease, increase, right? That's from the top. And we know it's going to be a concave down, and then a concave up. So if we draw our pieces, draw your concave down, increasing, decreasing, and then a concave up. And there's your answer. Easy peasy, right? Let's go do another one. And then you guys should take a break and relax and do some more later. All right, solve for x. What'd you do? Took out the x, right? You take out the x, factor this, factors of 12, they give you negative 6. Ooh, are there any? No. How do we factor this? You have to use a quadratic equation. Tricky, tricky. You're going to have to use that a lot in this because it's hard to get 3 things to be equal, and quadratic equation will be very useful to you in the future. So, B, A is 1, C is 12. Plug this in, and this is just for this. 6 plus or minus, what happens if you end up as a negative? This is 36 minus 48, so you end up with negative 12 down there. So if you end up, as soon as you get that negative in the radical, and you made sure that this number was positive when you squared it, that's undefined. So all that means is I only have one intercept. X equals 0 is my only intercept. Makes it easier. To find the y-intercept, you said what? X equals 0 solve, and guess what? Your answer is 0 as well. So our x and y intercept, so that means the graph is only going to cross to the origin, nowhere else. Vertical, horizontal, none because it's a polynomial. Next one we'll do a rational. So you'll get to have your asymptotes, don't worry. Negative infinity, highest degree term there is x cubed. Negative infinity to the third power is negative infinity because there's 3 negative signs, means it's going down. Positive infinity, we use x to the third again. Going up. There we go. Critical points, derive it. When you derive that, set it equal to 0 because polynomial, don't need to be undefined. 3x squared minus 12x plus 12. Take out a 3, right? Divide everything by 3. 0 divided by 3 is 0, so you can just actually just start with your x squared minus 4x plus 4. Are there factors of 4 that add up to negative 4? Do you have to use quadratic? No, because actually negative 2 and negative 2. X minus 2 equals 0, x minus 2 equals 0. So your answer is going to be 2 and 2 or just x equals 2. All right? Find the critical point. So take 2, plug into the original equation. Oh, take 2. 2 cubed is 8 minus 6 times 4 plus 24 is 8. So 2, 8 is the point where it goes from increasing to decreasing. Negative infinity to 2. 2 to infinity. Pick a number, 0 or 1, doesn't matter. We're going to plug it into here though. When I pick 0, 0 minus 0 plus 12 is 12. If I picked 1, 3 minus 12 plus 12 would have been 3. In both cases, the answer is positive. Positive answers are increasing. Let's pick 3. 3 times 3, so 27 minus 36 plus 12 gives you 3. Wait a second, it's still positive. That's weird. It's still increasing. Interesting. Increasing, increasing. Notice it always doesn't have to be opposite. For those of you guys that like to take shortcuts. Now let's do inflection points. You set f of x prime double prime x equals 0. Derive this equation, you get 6x minus 12 equals 0. Add 12, divide by 6, and x equals 2. Take your 2, plug it into the original equation. 8 minus 6 times 4 plus 24 is 8. So 2, 8 is indeed my inflection point. Notice anything about that point? Think. Negative infinity to 2, 2 to infinity, 0, negative 12, negative concave down. Pick 1, negative 6, negative concave down. Let's pick 3. 18 minus 12 is indeed 6. Anything above 3, obviously going to be positive as well. Concave up. So the concavity does change at this point. All right. Let's go, let's go, let's go. Intercepts. What did we say the intercepts were? Intercept, 0, only 1. Asymptotes. And x and y are the same, so you can just leave them. None. Easy graph so far, right? M behavior. Down, up, right? Critical points. Only 1, 2, 8. 2 over 8 up. Oh, point's wrong. Should be down. All right. At that point, increasing, increasing. Inflection point, 2, 8. Same point. All right. 2 over 8 up. Concave down, concave up. So what that means is I have to cross this, concave down, I hit this point, then I'll concave up. And if you guys ever knew what the cubic equation looked like, that's what it looks like. All right. Awesome. This should just be shifted down 1 to the 8, but pretend this is 8. Got it? All right, so try number 4, find your x-intercepts. Well, you said f prime x equal to 0, solve for x. So you have x-intercepts when the numerator is 0. All right? So you just don't worry about the denominator. So the numerator equals 0, 2x squared equals 0. Divide by 2, square root of 0 is 0. So you have 1 x-intercept. Find the y-intercept. Notice a different number now. You said x equal to 0. You just got to hope this doesn't become undefined. 2 times 0 is 0 over 0 minus negative 4. Is this answer undefined? No, it is 0. All right? So your y-intercept is indeed 0. Now you're going to go, get your intercepts? Good. Vertical asymptote is where f of x is undefined. So where is this example undefined? Not when the numerator is 0, but when the denominator is 0. So it's undefined when the denominator is 0. Okay? We don't care about under radicals right now because that, like I said, is a domain range thing. We just care about this. So we set the denominator, x squared minus 4 equals 0. Add 4 to both sides. Square root of 4 is positive negative 2. So you have 2 vertical asymptotes, one at negative 2, one at positive 2. Remember, vertical asymptotes are the ones that go up and down. End behavior. We have to use our end behavior now to find a horizontal asymptote. So left and right should be similar. So if plus and minus infinity give you the same one here, pick your L'Hopital's rule, highest degree terms. So you pick 2x squared and x squared. Negate the negative 4. 2x squared over x squared. Can I simplify this? Yes. These cancel out. My answer is 2. There you go. If this gives you a number, if the limits are the same and that same thing is a number, 0 is a number, by the way, and not infinity, so as long as there's not more exponents on top, okay, you have a horizontal asymptote, and that horizontal asymptote is y equals 2. So that's the one going across like this. So y equals 2 here, negative 2, 2. Got it? Critical points. This is where it's going to get a little bit annoying. So, right here. Now that's when it's equal to 0 or undefined. When you derive this, obviously you have to use the quotient rule because it is a quotient. FG. All right? 4x, 2x. All right? f prime g, 4x times this minus g prime f over g squared. All right? Now, what you have to do here is you have to distribute 4x cubed minus 16x minus 4x cubed. All right? Over, don't forget to go over g squared. Now, leave the g squared as g squared. 4x cubed minus 4x cubed cancels out. So you're left with negative 16x over x squared minus 4 squared. Not too bad. The first derivative is always easy. It's the second one, the critical number, that's the inflection point that's annoying. So set this equal to 0. So when you set it equal to 0, you set the numerator equal to 0. Divide by negative 16 and x equals 0. Set it equal to undefined, which means you set your denominator equal to 0. Square root of 0 is indeed 0. Add 4. X equals plus or minus 2. All right? We all good? All right. So that means we have 0, positive, and negative 2. But what do we know about those numbers? Let's see. So now when I plug 0 back into the original equation, I get as an answer 0. So that means my first critical point is 0, 0, which was also my x and y-intercept. Now what we do next is we plug in negative 2. Uh-oh, what happens when we plug negative 2 in here? Negative 2 squared is 4. 4 minus 4 is 0 on the bottom. When you have 0 in the denominator, answer is undefined. Now why is this undefined? Because this critical number right here is actually at a vertical asymptote. And it's the same for 2 if you remember from before, vertical asymptotes. This is also undefined, so that's also a vertical asymptote. So even though we're going to deal with the intervals here, we actually only have one critical point. Set it up. Smallest number here is negative 2. And then 0. And then 2. I wish I could drag with my thing, but I can't. All right, so negative infinity to negative 2. Negative 2 to 0. 0 to 2. And 2 to infinity. Test value. Negative 3. So we're going to take that test value and we plug it into here. Now watch what I can do. Negative 3 is a positive on top and a positive on bottom, right? So the number actually doesn't matter. All that matters is it's positive and it's concave up. Negative 1. 16 over 9. But watch this. Negative times a negative is a positive. Bottom's always going to be positive. Positive over a positive is positive, which is increasing, right? 1. 1 times this is negative 16 over 9. Negative. All right, deal with the signs. 3. Positive and negative is a negative on top, always positive on bottom. Negative number, decreasing. And you can always type in the numbers as well. So that means the graph is going to go up till it gets to the asymptote. After it gets to the asymptote, it goes up till it gets to 0, 0, down after 0, 0 till it gets to the asymptote, and then it decreases after the asymptote as well. All right? And once you can visualize what this stuff means, it makes it a lot easier as well. Now, inflection points. It's when you set it equal to 0 or undefined. So, this was the derivative we found from before, right? Way to derive that is using the quotient rule again. F is your numerator, G is your denominator. Now remember it's squared. F prime is negative 16. Now how do we find G prime? Because remember you have to use the, say it, chain rule. So your U is the inside, x squared minus 4. Your F of U, that to the second power, U squared. 2x, 2u. 2x times 2u. 2 times 2 is 4xu, or 4x times x squared minus 4. Put it back over there. As long as you leave everything like this, it's actually, you can take out these problems easy. Use this equation. F prime g, negative 16 times x squared minus 4 squared, g prime f. Negative 4x times this, times your f, over this squared is x squared minus 4 to the 4th power. When you square squared, it raised to the 4th. Now, instead of foiling all this and expanding and simplifying that way, look what you could do. You have x minus 4, x squared minus 4, x squared minus 4, right? I have 2, I have 1, I have 4. So I could take out at least this one. I could take out one of these two, leaving me with 1. And I could take out one of these 3, leaving me with 3. This will make all the expansions easier later on. So now, since I'm left here, I can go negative 16 here, times this, this, all right, and leave the bottom as it is. And that's a little bit easier. You don't have to double FOIL here and triple FOIL here and get really annoyed. All right, so negative 16x squared plus 64x, you combine like terms, all right, gives you 48x squared plus 64 over x squared minus 4 to the third power. So, not hard, a little bit tedious. So you're going to take this, you set the numerator equal to 0. That's when your f prime x equals 0. Subtract 64, divide by 48, and you get negative 1.5. Now, what's the square root of negative 1.5? Undefined. So there is no critical numbers based on the numerator. But look, there has to be something. So now you set the denominator equal to 0. That's when f double prime x is undefined. X is plus or minus. Those numbers seem familiar, don't they? So that is your vertical asymptote. All right, when you plug these back into the original equation, then remember these are their vertical asymptotes, so there is no actual inflection point. All right, but these are your critical numbers here. So negative 2 and 2. Your intervals, negative infinity and negative 2. Negative 2 to 2, and 2 to infinity. You good? 0 is not between these two. Some people think that. It's actually negative 3. If I type negative 3 into this equation right here, I get some type of positive number. The way you can also know it's positive is negative 3 squared, so the bottom is 9. 9 minus 4, positive number. When I square negative 3 here, positive over positive. So it's concave up. So it's concave up. When you get that asymptote, between there you pick 0. 64 over negative 4 to the third is negative 1. Negative is down. So between the two asymptotes is concave down. Here you pick 3 as an answer. Same as over there. Positive concave up after it's concave up. What does all this mean? Well, let's go graph it. So, what did we say our intercepts were before? 0. What did we say y was? Also 0. Asymptotes, here's where our graph changes. We said there's verticals at x equals negative 2 and at x equals positive 2. So you have two asymptotes. Horizontal, y equals 2. Y equals 2. All right, so right here, this gives us a little bit of an idea of what our graph looks like. Hopefully, let's see. Critical points, 0, 0. Inflection point. Oh, so right here, before here, it's going to increase. After here, it's increasing. So our graph is going to go increase, increase, decrease, decrease. So obviously, it's going to go up and down here. Well, we'll see how the other stuff works. Inflection points, negative 2 and 2. We don't know, but that does tell us concave up, concave down, concave up. How in the world does this work? Anyone have a clue? Try to graph this. Use this information and see if you can graph it. I'll give you a second. Because I know you guys aren't pausing. You're just going to copy. All right, now, because this is increasing, you can't cross through these asymptotes. So which boxes it has to be in? It has to be in this one, because you can go up here and you can curve up. All right? Now, end behavior ends at negative 2. So what happens is you actually hug the, positive 2, and then you increase. See? And it's concave up. Now, between these two is concave down. So why don't you try to do this one? Concave down between these two asymptotes. It increases, decreases, and it has to hit that point. And the graph you guys should have came up with was increases to this point, and then decreases back down. Now, let's see over here. Your graph is going to decrease. All right, so it goes down, but it's concave up. So if I decreased here, that means I would have to keep on increasing, and I can't cross through here. So where should it be? Up here. And that's your graph. Hopefully you guys got that right and are doing very well at this stuff. How you doing? You like this? I know you love it, right? All right, ready to do some more problems? Try problem number 5, which is a polynomial. All right, let's see how we're doing. Set f of x equal to 0 and solve. Negative 2x to the fourth plus 6x to the third plus 20x squared equals 0. Take out a negative 2, x squared. Makes things easier, doesn't it? Factors the negative 10 that I have there, negative 5 and 2. So negative 2x squared blah, 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 blah. Set this equal to 0. Divide by -2, square root, and x equals 0. X minus 5 equals 0, add 5, x equals 5. X plus 2 equals 0, subtract 2, and x equals -2. Good? All right. Looks pretty impressive. Y-intercepts. You set all the x's equal to 0. 0, 0, and 0 equal 0. Vertical asymptotes. Polynomials. So they are none for polynomials. Horizontal. None for polynomials. So that's pretty easy. This is an easy problem, isn't it? Highest degree term here is the 4th power one. -2. You can't forget the coefficient up front. Negative infinity to the 4th is positive infinity. -2 times positive infinity is indeed negative infinity. Means it goes down. -2 infinity to the 4th. -2 times infinity is negative infinity as well, so it goes down. Remember, it's not horizontal because unbounded behavior. Got it? All right, critical points. Oh, so derive. Only have to set it equal to 0 because it's not a fraction. -8x cubed plus 18x squared plus 40x equals 0. Now, obviously, you can't factor this. If you want, you could take out a 2, -2x. Hopefully that helps you, because then you get rid of the x cubed. Now, -2x squared and -2x equals 0. X equals 0, that's one critical number. In order to factor this, I'd use quadratic equation, unfortunately. Negative b plus or minus negative b squared, should be 81, minus 4ac over 2a. All right, this becomes 9 plus or minus 81 plus 80 times 4, 320, I think, over 8. You get 9 plus or minus radical 401 over 8. 9 plus square root 401 equal sign divided by 8. 9 minus square root 401. So you get negative 1.38 and 3.63. 2. Take these two numbers and what do we do with them? Plug them into the original equation. So we're also going to plug in the 0 as well. 0, 0 is our first point. Negative 1.38. 15.1 is my second point. And this is just algebra. Actually, numbers, just plug in the numbers. 203.3. All right. So these are my 3 critical points. The points where it switches increasing and decreasing. I'm going to go a little faster to explain this because it's taking forever. Negative 1.4. I just rounded this to negative 1.4. You don't have to be super accurate because the graph's not that accurate. You got 0 and you got 3.6. Here's your intervals between them, right? -2. You get 56. Once again, you're plugging it into this equation right here. -2, -2, -2. Not the original, but the derivative. Sign, positive, so it's increasing. -1 is between these two numbers. Negative decreasing, 1, right? Positive increasing, and what'd you pick? 4. Negative decreasing. So your graph is going to increase until it gets to this point, then it's going to decrease to this point, increase to this point, and then go back down. And it makes sense because we said the two things, so this is increasing, so it's coming from negative infinity, which we said before, and it ends up going back to negative infinity. So as long as your graph makes sense, you know you're doing it right. So we have our first derivative. We're going to find the second derivative. So negative 24x squared plus 36x plus 40. Now if we were doing this in class, we'd probably do about 3 of these problems a day, just so you guys know about how long it takes. Negative 4x, take out negative 4. All right. So 0 divided by negative 4 is 0. Left with this. Can't factor, so you have to use the quadratic equation, which hopefully you guys are doing good at now. And when you go to college, you have to use this a bunch, even if you're in like a basic math class. So it's good that we're practicing this. Negative, this is your B, your A, your C. You type it in, you get as an answer negative 0.74 and 2.24. Got it? Awesome. Type in negative 0.74, you get 7.9. Type in 2.24, and you get 17.4. So these are my 2 inflection points points where they change the concavity. Negative infinity, this is negative 0.74, this is 2.24. Your intervals, right? Number between these two, not 0, like negative 1 maybe. So you take negative 1, you plug it in here, you get negative 20. Negative number is decreased, concave down. So it's concave down up to this point. Between these 2 points, take a number like 0, 0, 0, 40, you could see. Positive, so that goes concave up. And then number here like 3, negative 68, so then it's going to go back down, concave down. All right? And now let's graph it. So we said before, intercepts were negative 2, 0, and 5. So the graph has to cross through those intercepts. We said there were y equals 0, same thing. There were no asymptotes. No asymptotes. We said the end behavior here. Okay? We're both going down, I believe, right? Down and down, yep. And we said the critical points were negative 1.5, so negative 1.5, 15. All right, which is right here, because these are all goes up by 25s. I had to do that with the 205 here. You got 0, 0, which we already have, and then you have 3.6, so this is 3.6, and all the way up here at 205. All right, so as you can see, between these points right here, the chart we made said the graph is going to increase to here, which makes sense because we have to come from negative infinity, cross through here. Then it's going to decrease to get to this point, makes sense, increase, and then decrease down forever. All right, so that's good. Now inflection points are negative 0.7, 7.9, and 2.2, 117.4. So between these two, you have concave down, concave up, concave down. So what this tells us is we're going to be a concave down, like an upside down U, a U, and another upside down U. Put everything together, concave down, increase, increase, decrease, decrease, increase, concave up, and finish up like that. All right, everything you do makes sense. Put it all together. You guys can create fantastic graphs like this. See this? You ever think you could do this without a calculator? And use Desmos. Desmos is a great tool to help check your answers. All right, I always use it just to make sure I don't make mistakes. You should do very well, all right? So this is what your graph ends up looking like. Let's try another one, number 6. This is like a little more than the halfway point. All right, another polynomial. All right, so set the top equal to 0. Remember, numerator has to be 0. 2x squared minus 8 equals 0. Add 8, divide by 2. Oops, square root of 4 is plus or minus 2. Right? B-intercept. What do you got? B means the y-intercept, sorry. I'm at the hour mark here. So you get negative 8 over 16. Ooh, look at that. We got a nice one. We got one of 1/2. So we got 2 intercepts here. Asymptotes. To find the vertical asymptotes, you set when it's undefined, the denominator equal to 0. So all we have to do is set the bottom equal to 0 because the top gives us our x-intercept, the bottom gives us our asymptote. So x squared equals 16. Square root of 16 is plus or minus 4. So you have 2. You have one at negative 4 and you have one at positive 4. Let's see if there's a horizontal. If we can get a number out of here, we take this, use L'Hopital's rule, take the highest degree terms. Oh, look at that. X squareds cancel out. And our answer is 2. Again, just coincidence. Since they are the same, our answer is y equals 2. All right. Now what I want you guys to do is use your quotient rule. Oops, sorry about that. To find the intercepts. I'm just checking the time right here. Should be done. 2x squared minus 8, x squared minus 16, fg. F prime, 4x, g prime, 2x. F prime g, 4x times x squared minus 16, g prime x. 2x times 2x squared minus 8 over g squared. All right? Just a simple quotient rule. Sorry, I'm getting more close to your camera here. Now, cancel the stuff out. Wait a second. Nope, can't cancel anything out. What you can do is you can distribute 4x cubed minus 64x minus 4x cubed plus 16x, okay? Now, sorry, I was jumping up ahead. You can cancel out 4x cubed minus 4x cubed cancels out. Negative 64x plus 16x is minus 48x. All right, and the bottom stays the same. So now we set this equal to 0. We set the numerator equal to 0, right? Negative 48x equals 0, x equals 0. So that is our first critical number. When you set it equal to undefined, you set the denominator equal to 0. Square root of 0 is 0. Add 16. Square root of 16 is indeed plus or minus 4. These numbers should look familiar because we already got them in the previous step. So when you plug these in to the original equation to find the actual critical points, when I plug 0 in, I get 1/2. Remember what 1/2 was? That was our Y-intercept. Just look to your left. So 0, 1/2 is also a critical point. So we're going to have it go switched over, going up and down, probably at that intercept. If you plugged in negative 4 squared is 16. 16 minus 16 is 0. So it's actually undefined. So the reason for that is that's our vertical asymptote. So we may change over from increasing to decreasing at the asymptote. And when you plug in 4, you also get undefined, which is our other asymptote. So let's go. We got negative 4, we got 0, we got 4. So even though these are undefined, you still have to use them for your intervals. Negative infinity to negative 4, negative 4 to 0, 0 to 4, 4 to infinity. Good? Test value here has to be on that side of negative 4. So you just use negative 5, you get a positive number, it is increasing. So the graph is going to go up until it gets to the asymptote right here. And then right here, let's pick like negative 1. Guess what? After the asymptote, it's still going to be increasing. Until it gets to this point right here, you pick 1, plug 1 into, and we're plugging everything into this equation right here. So after you plug 1 in, the graph is going to go down. So at 0, 0, it's going to start decreasing. So it's going to increase, increase, decrease, and then I bet this is going to be decreasing. It's always like symmetrical. Yep, look at that. Negative and decreasing. So hopefully you got increase, increase, decrease, decrease. And if you didn't, go back and check your work. Here we go. We have the derivative, right? From the previous problem. Now in order to derive this, we have to use the quotient rule again. Negative 48x, x squared minus 16 squared, negative 48, and we have to use what rule? Again, chain rule. So way to use the chain rule is u is the inside, f of u is the outside. 2x, 2u. 2x, 2u is 4x, and then you plug u back in. Do not distribute, because if you distribute, it becomes a little trickier later on. We like to keep all these x squared minus 16s. F prime g, g prime f prime g, g prime f over g squared. X squared minus 16 squared is x squared minus 16 to the 4th power. Remember, squaring a square, 2 times 2 is 4. Now, the reason I kept all the x squared minus 16s, once again, I've been saying this multiple times, even on the last, 4.4 lesson, you're going to cancel this out. I have 1, 2, and 4. So all these go away. One of these 2 leave me with 1. And one of these 4 leave me with 3. So I got negative 48, x squared minus 16, minus 4x, times negative 48 over x squared minus 16 squared. I'm going to distribute the negative 48, distribute the negative 4. Negative 48, x squared plus 768, plus 192x squared over this. These combined, giving you 144x squared plus 768 over that stuff. All right? Now in order to solve this, f prime x equals 0, f double prime x equals undefined. When I set this equal to 0, the numerator equals 0. Subtract 768, divide by 144. Can't take the radical of a negative, so it's undefined. No inflection, no critical number there. Set the bottom equal to 0. This looks familiar, right? We've been doing this one multiple times. Square root of 16 is indeed plus or minus 4 once again. And what did we say plus or minus 4 was before? Those were our vertical asymptotes. All right, we just did it on the previous problem and we did it before. So we have 2 inflection, not really points, but inflection spots. Negative 4 and 4, no 0, like before. Negative infinity to negative 4, negative 4 to 4, and 4 to infinity. Take negative 5, plug it into this equation right here. You get a positive number, means it is going to be concave up. 0, 768 over negative 16 cubed is a negative number, concave down. And pick a number like 5, should be a positive number, it is indeed, and that's concave up. All right, so where's that? Negative 4 is here. All right, we're going to have a concave up. Between negative 4 and 4, concave down, and then afterwards, concave up. All right? Why don't you guys graph it now? Go. All right, let's see if you graphed it right. Intercepts, negative 2. and 2. Oh, there are 2 intercepts. Vertical asymptote. Oh, y is 1/2. Right there is our y-intercept. Vertical, -4 and 4. Horizontal, y equals 2. Any questions yet? This is giving us a good idea what we're going to do. Critical points. 0, 1/2. So here's your critical point, and what we said is between these points it's going to be increasing everything before this point and decreasing everything after this point. Inflection points. -4 and 4. Concave up, concave down, concave up. All right? So I'm going to increase from here to here. Well, I can't increase through here. So do you remember what this side looks like? Come on. Yeah, it's the U. And now this one's going to increase till I get to this point. So I have to cross through here, hit this point, and then decrease. And it's concave down. Oh, I did that over there first. And there's your graph. Is that what you got? If that's what you got, I'm very proud of you. If not, hopefully you can get it by the next couple problems. All right, problem number 7. 7, 8, 9, 10, 11. 5 more. All right, X-Intercepts. I'm just going to shoot through these problems. Pause me when you need to. So, take out an x. X squared plus 5x minus 6. Factors the -6 that add up to 5 is 6 and -1. X equals 0. X equals -6 and x equals 1. Y-intercept. Type in 0 for everything. Y equals 0. Anytime you have an x equals 0, you're automatically going to have a y equals 0. No vertical or horizontal asymptotes because it's a polynomial. Left limit behavior is cubed. So when you cube the negative, it becomes negative going down. When you cube a positive, it stays positive, goes up. All right, you're going to have to use quadratic here because there is no easy way to do this. A, B, C. -10 plus or minus radical 100 plus 12 times 6 is 72 over 6. Oh, there you go, 172. Add it, subtract it, you get your two numbers, -0.38 and 0.05, or 5/10, -3 and 8/10, and so on. Type in -3 and 8/10, you get 40.1, or 40 and a tenth. Type in a half, you get -1 and 6/10. All right, those are your two equations. -3.8, 0.5, interval, interval, interval. All right, number between these two, -4 all the way that way. I just went with the closest one. You're typing it into this equation right here. You get 2, which is positive, which is increasing. So you're increasing till you get to this point. Between these two, you have a big 0, which is negative. 0, 0, -6, obviously, is down. So between these 2 points, your graph is going down. And then after you get to this point, pick any number above this. It's obviously going to be positive, which is increasing. So after this point, graph is increasing. All right, let's go with the concavity. All right, your inflection. Have your first derivative, take the second derivative. Very simple, 6x plus 10 equals 0. Subtract 10, divide by 6, and x equals -10 over 6, or -5/3. Just reduced it. Or -1.67 if you want. Or -1.7. You can round it even easier. All right, type that into your equation. You get about 19.7. So our equation is -5/3 or -1.7, 19.7. I just rounded to the 10th because you can't really see a tenth on a graph anyway, or 100th, so it makes it easier. Take the answer, -1.97, 1.7, plug it in here. Interval, interval. Number between these two is not -1 or 0. That's on this side. It's like -2. Plug in -2, -12 plus 10 is -2. Negative means concave down. Take a number here. I always love 0. 0 plus 10 is 10. And that's positive number, concave up. So you got your concave down, concave up. There's your 1.7, -1.7. Got it? So let's do the graph. Your intercepts were -6, 0, and 1. Y equals 0, so you have the same intercept here. Your asymptotes, polynomials, so there are no asymptotes. End behavior, we said it goes coming from the bottom here, and it's leaving at the top over here, which makes sense because it is an x cubed. Let's see, what else do we got here? Critical points. -3.9, 40. and you got a half and negative 1.6. Each one of these two is 1, so each one of these dashes is a half. So look, we're probably going to go here, down to here, and then up to here. All right? We just need to know the inflection points. So like I said before, increase, decrease, increase. Inflection points here, negative 1.7, about 20, so somewhere around here. Everywhere before this inflection point is concave down, so it's like a U to here, and then it goes the U the other way. There you go. See how easy this is once you get the hang of it? Simple, 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 simple. That one took barely any time. Let's fly through the next one. Problem number 8. 8, 9, 10, 11. Almost there. So X-intercepts. Set the 8, numerator equal to 0, right? So 9x squared minus 25 equals 0. Add 25 divided by 9 and take the square root. You get 5/3 or plus or minus 1.6 repeating, or plus or minus 1.7. Y-intercepts, you set x equal to 0. Uh-oh. You get 0 over 0. Negative 25 over 0, which is undefined. What does that mean? It means there's no y-intercept. It's never going to touch the y. Vertical asymptote. You want to know why it's never going to touch the y? Because when x cubed equals 0, you have your vertical asymptote. So when x equals 0. So the y-intercept is actually your vertical asymptote. All right? Left and right behavior. Look what happens here. Take your highest degree term, so the 25 goes away. When I cancel this out, I'm left with 9 over x. Well, when I plug in infinity here, 9 divided by infinity is 0. So my horizontal limit is 0. Can you have a horizontal asymptote of 0? Of course you can. Because 0 is a number. All right, critical points. Derive this using your quotient rule. All right, FG, 18x minus 0, 3x squared, right? F prime G, 18x times x to the third power minus 3x squared times this over this squared. When you square a cube, 3 times 2 is 6, all right? X to the fourth minus 27x to the fourth plus 75x squared. 18 minus 27 combined like terms is negative 9x to the fourth plus 75x squared over x to the sixth. Now, can we cancel anything out here? Yeah, you can take out an x squared, leaving this as an x squared, and I can take out 2 here, leaving this as x to the fourth. All right, makes things a heck of a lot easier. Got it? So, when f of prime x equals 0, set the top equals 0. All right, negative 9x squared equals negative 75. X squared equals 8.33. X is plus or minus 0.29. Now, I kind of cheated a little bit taking the x squared out of here, knowing that when I set the denominator equal to 0, it's going to be 0 anyway. Otherwise, you would have to leave the x up here, because one of the answers for this 2 would be 0. But I knew it was going to be on this bottom anyway, so it didn't matter. So I have 3, 0, plus or minus 0.29. I'm going to plug them all into this equation. When I plug 0 in, undefined, because it's a vertical asymptote. When I plug negative 0.29 in, I get negative 0.21. So my point is negative 0.29, negative 0.21. When I plug a positive 0.29 in here, I get positive 2.1. So my other critical point is 2.9, 2.1. All number work. Negative 2.9, 0, 2.9. Negative infinity to negative 2.9. Negative 2.9 to 0. 0 to 2.9. 2.9 to infinity. Doing good? Negative 3. That's really close, but it's less than it. Negative 0.07. The higher negative, the lower negative numbers you pick, the bigger this number will be. But in all cases, the number is negative, so it's decreasing. So the graph is going to be going down, which makes sense. All right. Down. This way. It hits this point. Negative 1, positive. So then it's going to start going up. Positive increases. I bet this is going to be a negative. 1. No. It's still increasing. Look at that. See? You can't guess. Because when I plug 1 into this equation, I get 75 minus 9 over 1. All right? Here, take 3, plug 3 in, and you get negative 0.07, which is negative, which is decreasing. So the graph's going to go down, up. Oh, there's an asymptote here. And then it's going to go up and down. All right, so let's see what this all means. All right, so take your first equation, derive it, and continue on. All right, so you derive that one. Your f is your numerator. Denominator, negative 18, x plus 0, 4x cubed, f prime g, g prime f. So negative 18x, x plus 4 minus 4 times that. Now, we can't reduce this yet, but what we can do, 4 times 2 is x to the 8th, negative 18x to the 5th, plus 36 x to the 5th minus 300x cubed. All right, combine like terms, 36 minus 18 is 18x to the 5th minus 300x cubed over 3x to the 8th. Now, you can also take this out, knowing that I'm going to have a 0 on bottom. Take 3 out, take 3 out, take 3 out, leaving me with 18x squared minus 300 over x squared over x to the 5th, sorry. So the top equals 0. All right, add 300, divide by 18. Answer is plus or minus 4.1. Got it? Numerator equals 0. That's an easy one. X to the 5th equals 0, so x equals 0. So 0 we know is our vertical asymptote. To find these actual critical numbers, you're going to take 4.1, plug them into your original equation. When I plug a negative in there, I get negative 4.1, negative 1.8 as my first inflection point. Take the positive 4.1, plug it into the original equation, and I get 4.1, 1.8 as my second inflection point. Now to find the concavity, negative 4.1, well, yeah, 0, positive 4.1, negative infinity to negative 4.1, negative 4.1 to 0, 0 to 4.1, and 4.1 to infinity. Finish the chart, which is very easy. Can't be negative 4, can't be negative 3, can't be 0, has to be negative 5 or less. So let's just go with negative 5. You get a negative number, which is concave down. So I have concave down up to this point. Negative 1, I get a positive, which is concave up. So between these 2 points, between this point and this asymptote, it's concave up. Concave down between this asymptote and this point. And then between this point and infinity, it is concave up. All right, you can pick your own numbers. You're going to get the same last 2 rows. You may get a different second row, but these rows are always going to be the same no matter what numbers you pick, as long as they fall in the right test interval. Let's see what our graph looks like. Negative 1.7, positive 1.7. Your asymptotes are vertical, x equals 0, so that is our, I had to make it thick so you can see it, our actual y graph, all right? Your end behavior, going to the left, going to the right, both at 0. That's weird, right? So what is our end behavior? Our end behavior is going to be pretty much almost like a horizontal asymptote here. Not a total asymptote, though, because these points are on the line. So there are things that do hit. Critical points, negative 2.9, negative 2.1, 2.9, positive 2.1. So let's see. Between these points, what happens is the graph is going to decrease. Oh, wait. This is an asymptote, so it can't really cross here. So it's going to come from here to here, increase, up, and there's a graph. And then after this asymptote, it's going to increase till it hits here, and then it's going to decrease, but it has to hook here. So let's look at our inflection, negative 4.1, 1.8, and so on. And 4.1, 1.8. So our concavity here, we said this is concave down. So it should be down until it gets to here, and then it's going to switch to a concave up. Now let's see if you can graph that. I gave you some hints along the way. You ready? Concave down until it gets to this point. Now it's going to be concave up. Now it still has to decrease till it gets to this point, and then it increases. So you're going to have like a little decrease, and then an increase. Now you can't cross this asymptote. So it's going to shoot up to there. This isn't exactly what it looks like, but it's a good idea. So it's going to go, whoa, like a little wiggle. Can you get this side? Okay, let's look. Concave down. So you're going to probably come from here, increase till you get to there, right? To here, there's your concave down. And concave up. Remember, you're hugging this. There you go. even though this is kind of like an asymptote here, you can be on different sides of it because you're still approaching 0 from both sides. All right, and this is like the best looking curve. So if you got that one, you got real good. All right, let's do 9, 10, 11. X-intercepts. So you graph, take out an x, factor, x equals 0, subtract 1, x equals -1, add 7, x equals 7. 1, 2, 3, good. Y-intercept, plug in 0, x, y equals 0. See? Vertical, horizontal, same answer. And the answer is none. None. Good. End behavior. Take the highest degree term. X cubed. X cubed negative to the third power is negative. Means it's going down. Positive. Up. Look at that. Under a minute. All right. Critical points. You are going to have to use the quadratic equation here. So it is going to take a little bit longer. You derive this equation. A, B, C. Negative. So this becomes 12 plus or minus 144 plus that over 6. Two answers, -0.5, -0.5, and -4.5. All right, both these numbers plugged into that equation. So cube it, square it, multiply by -6, multiply by -7, -0.5, 1.9. Take 4.5, plug it in. All right, -61.9. All right, 4.5, -61 and 9/10. Negative infinity, -0.5. -0.5 to 4.5, 4.5 to infinity. Number between these two is -1. 8. 8 is a positive number. Conclusion is it is increasing before it gets to this point. Between these two, you pick 0. 0, where is that? Put 0 in there, you get -7. Negative. So between these 2 points, it's going to go down. And then here, you pick like a 5, plug it into this equation, and you get positive number, which is increasing. So, what you have here is your graph is going to be increasing, decreasing, increasing. Okay? Thank you. Now, when you do your inflection points, in case you missed it, you're going to take the derivative of your second derivative here. Derivative of this. 6x minus 12 equals 0. Add 12. Divide by 6. And you get x equals 2. Loud people in the house. So you have one inflection point. Take your 2, plug it into the original equation. And your actual point is -30. So 2, -30 is the actual point. Remember, critical number, inflection point. Negative infinity, 2. 2 to infinity. Negative infinity to 2 is, pick like 0. 0 minus 12 is -12. Negative number, concave down, so it's going to be concave down. Between these two numbers, pick like a number like 3. 18 minus 12 is 6. Positive is just concave up. So you have concave down before you get to this point, concave up after you get to this point. All right? Hopefully you're flying through these. Intercepts here are -1. Notice each one of these is a half. Each one of these is about 3. So -1, 0, and 7. All right? Asymptotes. Y equals 0 is the y-intercept. Anytime x is there, y is there. No asymptotes because it is a polynomial. End behavior is going to come from down, so it's going to come up. All right, end behavior here is positive here. And anytime you have a odd number here, typically it's going to be opposite. Negative, positive, positive, negative. Anytime it's even, it does the same thing. If it comes from the bottom, it leaves at the bottom. If it comes from the top, it leaves at the top. Critical points, you said. -1/2 and 1.9. So we got 1 up here. And then we got 4.5, -61.9. All right. So let's look. What this graph says to do is it says to increase through here till you get to this point, and then it says to decrease. You have to cross the intercept all the way down here, and then you're going to increase and cross the intercept there. So the last thing you know to do is there's only one inflection point. So 2 over, 30 down. And what happens at this inflection point is everything on the left is concave down. Everything to the right of this is concave up. So that's my inflection line. So that means that coming here, concave down till you get to this point. After this point, decrease and increase with a concave up. All right? And that's it. That's your graph. See how quick we did that one? 2 left. All right, so X-intercepts. Solve f of x solve for x. So you're going to make the numerator, once again, has to equal 0. Negative 2x squared equals 0. Divide by negative 2 and square root of 0 is indeed 0. So you have one x-intercept. Y-intercept, set everything equal to 0. 0 over negative 9 is good. That's an answer that is 0. So your origin is your only intercept. Vertical asymptotes, where f of x is undefined. So that is when, what happens? The numerator equals 0. So when x squared minus 9 equals 0, you're going to have a vertical and up and down asymptote. Add 9 and square root it. That's plus or minus 3. All right, let's see if there's a horizontal. Negative 2x squared over x squared minus 9. Use L'Hopital's rule. Get rid of the negative 9. So you have negative 2x squared over x squared. Cancel out the x squared. Your answer is negative 2. So you have a horizontal since the numbers are the same and it's an actual number. It's negative 2. All right. So plus or minus 3 going up and down. Negative 2 going across. All right. Critical points. You derive this equation. So when you derive this equation, very simple. F is negative 2x. G is x squared minus 9. F prime is negative 4x. And G prime is 2x. All right. Now, f prime G, G prime F, negative 4x times x squared minus 9 minus 2x squared equals x squared minus 9 squared. All right. Negative 4x cubed plus 36x plus 4x cubed. That's squared. Your G squared. Cancels out. 36x over x squared minus 9 squared. All right. Set the numerator equal to 0. That's when f of x equals 0. Divide by 36, x equals 0. So one critical point there. Set the denominator equal to 0 when it's undefined. So square root of 0 is 0. Add 9. Square root of 9 is plus or minus 3. So you have 3 critical numbers here. You're going to take these critical numbers, plug them into the original equation to see what your critical points are. You plug in 0. 0 over negative 9 is 0. So one critical point is 0, 0, which is your origin, your x and your y-intercept. When you plug negative 3 and 3 into the answer, this becomes 9. 9 minus 9 is 0. All right. So negative 18 divided by 0 is undefined because it's your vertical asymptote. When you plug 13 in here, you get the same answer, negative 18 over 0, which is also undefined, which is your other vertical asymptotes that we found before. So even though these are critical numbers, your only critical point is at 0, 0. You can still use them to do your intervals, negative 3, 0, 3. All right. Negative infinity, negative 3. Negative 3 to 0, 0 to 3, and 3 to infinity. Let's pick negative 4 and plug it in 2. Where's my equation? Right here. All right, so you got a negative over a positive, which is a negative, which is decreasing. All right, let's say negative 1. Negative 36 over positive, which is also a negative. It is decreasing. So everything before 0, your graph is going down. It's going this way, decreasing. After it gets to 0, pick 1. 36 over that is obviously increasing. And then any number that's actually positive, the top's always positive, the bottom's always positive, so that is also increasing. So your graph is going to decrease till it gets to this asymptote, decrease after the asymptote, increase after it hits the origin, and then increase after the asymptote at 3. All right? All right, so now, inflection points. Hurry up, go. Don't do it again. All right, what you're going to do here is you're going to derive this equation once again. So derive that equation using the quotient rule and the chain rule. All right, f is my numerator right here, 36, negative 36x. Sorry, this says 36. Gotta erase that negative. All right, so this is 36x. Should not say negative there, but I got the right f prime. All right, g prime. In order to find u, you got x squared minus 9, u squared, 2x, 2u, 2xu, so it's 4x times x squared minus 9, which goes back in here. All right, now, when I do this, I have 36 times x squared minus 9 squared minus 4x, x squared minus 1 times, like I said before, this says 36. Now, you have to cancel out these things right here. All right, when you cancel them out, this whole thing goes away. One of these 2 goes away. One of these 3 goes away. All right. And then what you're going to do is end up with 36 times x squared minus 9 minus 4x times 36x over x squared minus 9 cubed. Distribute 3x squared minus 324 minus 144 squared, all right? And this stays at the bottom. Combine like terms, you get negative 108 x squared minus 324 x squared minus 9 cubed. All right, you're going to set the numerator equal to 0. All right, add 324 divided by 108, x squared equals negative 3. Because it's negative, it's undefined. There is no inflection points, inflection numbers out there. All right, set the denominator equal to 0. Add 9, square root it. You get plus or minus 3. Remember we said what are those? Those are asymptotes. So there actually are no inflection points, but you are going to change your inflections at the asymptotes. All right, so we got negative 3 here, and we got positive 3 here. From negative infinity to negative 3, negative 3 to 3, and 3 to infinity. Let's pick negative 4. If you plug that in here, you get negative 0.58, which is negative and concave down. So it's concave down before the first asymptote. Between the second two asymptotes, you pick 0, negative 324 over that. Negative over negative is a positive, which is concave up. And then 4 is a negative, so it's concave down. So you have a concave down, you have a concave up, and then you have a concave down. So let's see what this graph looks like. So your intercepts, x equals 0, y equals 0, so it's the same intercept. All right. Your vertical asymptote, x equals negative 3, and x equals positive 3. All right. Horizontal asymptote, y equals negative 2. All right. Critical points, 0, 0. Inflection point. Well, the inflection point is at the two asymptotes right here. The critical point right here, it's going to decrease till it gets to this point and increase afterwards. Your concavity is down, up, down. So it's concave down here, concave up this whole section, and concave down afterwards. So why don't you try to use this information here to try to come up with your graph. All right, so concave down means, well, since I'm decreasing here, I can't decrease through here, so I'm not in the top here. I have to go here, and I can hug this right here. I can also hug here, so this looks perfect. Concave up means it's like a U. So I can't do a U down here because I have to be here. I have to decrease to this point, increase afterwards. Oop, I did this one here. So concave down is pretty much a mirror image over here and here. And then you have your U right there. All right, so decrease, increase, and because this is concave down and it's increasing the whole time, is here. Typically you have mirrors, so if I'm in this box, I'm in this box, if I'm here, here. But you just have to figure out where your boxes are, and the easiest way is to use this piece, because you always have to connect to your critical point and your intercepts. All right? Are you ready for the last problem? Good. Easiest one. Set the numerator equal to 0. Negative 5x equals 0, x equals 0. Y-intercept, solve for 0. So 0 over negative 3 equals 0. Vertical asymptotes. All right? F of x is undefined. All right, so you set the denominator equal to 0. When x minus 3 equals 0, there's only 1 at x equals 3. Ooh, that's interesting. All right, end behavior, negative 5x over x. We don't need the negative 3 because of L'Hopital's rule. Get rid of the x's, and your answer is negative 5. So our horizontal asymptote is at negative 5. So we got a 3, negative 5, and this. Now you could fill the graph out as soon as you do these, which I usually do. And I usually do that in class, but obviously I don't have two TVs here. Critical points. The first thing you do is you derive that. F is negative 5. G is x minus 3. Negative 5 and 1. All right? Negative 5 times f prime g, x minus 3, minus 1 times negative 5x. So you get negative 5x plus 15 plus 5x over x over g squared. Negative 5x and 5x's cancel out. You're left with 15 over x minus 3 squared. Now, when you set this equal to 0, 15, does that ever equal 0? No. So there's no critical point there. When you set it equal to undefined, x minus 3 squared equals 0. Square root of 0 is 0. Add 3. So you only have one critical point, and that's at x equals 3. But what happens when you plug the 3 in? To get my actual critical point. Critical number Plug it in to get the critical point, the original equation. You get negative 15 over 0, which is undefined. Your actual critical number is at the asymptote. So you really have no points on the graph. All right? Strange. So you have 3, which is my asymptote, negative infinity to 3, and 3 to infinity. So you plug in, let's take a test number such as 0. Plug it into the, where's my derivative? I lost my derivative. Here. 15 over 0 minus 3 squared is 15 over 9. Or 5 over 3, which is positive, which is increasing. Now say I pick a number here like 4. You get 15 over 1, which is 15. 15 is also positive, so it's increasing. So the graph increases till it gets to the asymptote, and then it increases again. Interesting. All right, let's do our inflection point. What we're going to do is we're going to take our first derivative, derive it again. All right, quotient rule. F is 15. G is x minus 3 squared. F prime is 0. Ooh. G prime, we use our chain rule. U is the inside, F of U is the outside. 1 and 2u. 1 times 2u is 2 times x minus 3. So you have 2 times x minus 3 here. F prime G is 0 times this, which is 0, minus 2 times this times 15. Now, I could still cancel things out if you want, or you could just factor everything. 0 times this anyway is going to be 0. So really just negative 2 times 15 is negative 30. Oh, here I got it right here. Negative 2 times 15 is negative 30 over x minus 3 squared. If you want to just distribute this and solve it that way too, you can. It doesn't really matter. Now, when I set this right here, numerator equal to 0, does negative 30 ever equal 0? No. So there is no inflection point based on this being 0. So we set the denominator equal to 0 when we find it to be undefined. Now, as we did before, cubed root, add 3, x is 3. What did we say 3 was before, though? That's my vertical asymptote. So we have negative infinity, infinity are endpoints, and a positive 3 goes right here. Negative infinity to negative infinity to, that should say positive 3. And then 3 to infinity, that's just a positive. All right, our test value here, let's pick negative 4. Actually, I should have picked 0, it doesn't matter. If I pick 0, negative over negative, negative. And then if I pick 1.11, positive. So concave up, concave down. All right, yeah, it's negative regardless, doesn't matter. Where's a positive, positive? 0 is, this should be 0 here. So erase that. I'm not going back and redoing this whole thing. 0's on this side, so that's positive. Negative 4 is actually negative. These are both negatives, right? Negative 4 is positive too. All right, and then if I pick the number between these two, such as 4 minus 3 is a positive 4, negative over positive. So let's look at our graph. I don't know how I had that backwards. All right, there's my intercepts. My vertical asymptote's at 3. My horizontal asymptote's at 5. Critical point is this. Inflection point is also this. So this is going to increase, and this one right here is going to concave down, concave up. These are reversed. Concave up and concave down. All right? Reverse these and reverse the other thing. I'll put the right answers on the thing. I'm not going back to fix the whole thing just for that though. All right, so that is your whole review. Hopefully you guys did well on it. This is the right thing you should have graphed. It goes through the intercept, concave, concave. Notice increasing, and then you have your asymptote. All right, so good job, and hope you enjoyed the show.